Okay, so in this tutorial we are going to use finite element analysis to see how well this bracket would hold up to holding something on top of it. So the first step is with FEA is once you have your design completed is you go up here to the simulation workspace and you pick static stress test. So you create the study. And so now once we're in the study, you'll notice our toolbar has changed. And so the first thing we need to do is we need to tell Fusion what parts of this model are going to be not going to move. So in this particular case, what I'm going to do is I'm going to put screws through these two holes here. So that means, and then we're going to anchor it to the wall. So that means that this part down here is not going to move. It's going to be anchored by two screws or bolts. Doesn't really matter. What matters is that I tell Fusion that this part of the model can't move. So that's called a constraint, and it's a structural constraint. So what I need to do is hover over each of these spaces here. And now over here, it's going to be a fixed constraint, meaning that it doesn't move. I've got two faces, and then I need to say which axes it's restricting movement on. So in this particular case, these are going to be attached to the wall, so that means that they can't move to the left, which is the x-axis, or the right, which is the x-axis. They can't move to the left, and they also can't move they can't move up and down, and they can't move forward and back. So that means that it's constrained on all three axes. So we'll keep all three of these selected, and we will click OK. So once you've done that, we need to talk about the document tree over here. So you'll see here is where I'm building my study. And if we, under load case, if I click the down arrow here, you can see that I've now added these constraints right here. So if I want to go in and edit them again, I can just click on the pencil and edit them. But that's all we need to do for now. Okay, so the next step is I need to add my load. So in this particular, so we go up here to loads, okay, and sorry, we go up here in the toolbar to loads, and we're going to add a structural load. There are other loads, but we're just going to focus on structural load. And so the first thing we want to do is, it could be force, it could be pressure. We're just going to stick with force, and we're going to click on the top surface here, and there we go. And so that we're going to be adding the load directly down onto there. And so now we need to talk about how to tell it what force to add. So the units is going to be newtons. So the easiest thing, what I would suggest is decide how much weight you want it to bear, load. So I've already decided for another project that I want this to help inform you about. I'm going to try and make something that can hold 30 kilograms. So what I'm just going to do is go up here, and I'm just going to type into Google. In fact, you can see I've already done it, 30 kilograms of force in newtons, and it will tell me 294 newtons. So I'm actually going to round that up to 300 newtons of force. And so you can now see that under loads, I've now got this force in here. Okay, so I've got my constraints set up. I've got my force set up. If I click on here on the pencil, I can edit it. And so the last thing is we need to make sure we turn on gravity and make sure that gravity is simulated going in the same direction as gravity would be in real life. So once I have done my constraints and added my forces and gravity, I can now go up here and solve this analysis. So I recommend doing the pre-check first. So, okay. So I forgot about material properties. So what I'm going to do is go over here to materials and study materials. And right now it is set to same as model. So what I'm going to do instead is I'm going to go here, and I'm going to go to my Fusion printing materials, which I'll teach you how to upload in a different tutorial. And now if I click down here, I can get PLA, which is the material I want. I'm going to click OK. So now I've got PLA set up as my study material. So all of the Young's modulus and everything else for PLA has been added to this model. So let's try that now. Check. So now my study is all set up. I got the green check. So then I go solve, and I go solve. And I've got my one study set up to go, and then I go solve one study, and it will start to solve it. So this might take about 5 minutes. You can see in status here that it's starting to work on it. If you click X on here, you can always check your study again by going up to the top right corner in notifications and click on view job status, and you can see how it's going. Okay, I've already run this, so what we'll do is we will pause this video for a second here. All right, so here is this. So when it's finished running this study, you will get a green check beside the study. And when you first shows you, it will show you the results. So this is what I want to show you here. So this gives you lots of information you can use to help you with redesigning your product. So as you can imagine, because I've just anchored the bottom here to the wall, when I add weight to the top here, the most force is actually going to be right here above the part that is anchored to the wall. And so you can see right now the safety factor for all of this is red. Basically it says this is going to break. And then you can also see actually up here, that's also red up there. Okay, yellow is not much better. So this piece will completely fail under the forces I've added to it. So this will give you, so if I was now going to try and redesign this, I would have to make some parts of this thicker, or I could add more ribbing to some parts of this, or trusses to counteract the loads. Now that's safety factor. If we go to stress, this gives you a better idea where the stress load is, right? So you can see red, yellow, and green is sort of the most stress is in this part of my model. If I go to displacement, I can see which part of my model actually displaces the most, right? So I could maybe add a truss going all the way out here to the edge to make sure it doesn't displace. And then there's some other views here as well. Reaction force. So this is like, so you can see here, this is the force pushing back on the constrained part here. Strain is sort of very similar to stress in terms of information to help you with designing. Okay, so you can go finish results, and your study will just be right there. So you can do other studies on this as well, and they will just show up here. And that's how you do a finite element analysis.